Hello everyone, welcome to my YouTube channel. Today in this video, I am going to model this elevated water tank in ETABS. So here basically we see the water tank in which there are square columns, 8 numbers of size 600 by 600 mm and are located at a radial distance of 4500 mm from the center, and this outer periphery is a dome periphery which is uh, at the radial distance of 6250 mm at our outer surface. And if we see in the sectional elevation, we see the beams are 500 by 600 mm, which means depth of 600 mm, four beams of 600 mm, and another top beam where the dome starts, it is 900 in depth. It means the floor height of 3350 plus 650, it means 4000 floor height and 4250 floor height of one story. I will model from the ground floor, ignoring these ground floor beams and the below the ground floor, and a dome shear wall of this slope shear wall of 300 and this one is 250. I think I will keep both these two shear wall of 300 mm, and this dome type slab, lower slab of dome type is 300 mm, and the upper dome slab is 100 mm with a manhole cover. I will ignore the manhole cover, and upper ring beam of 300 by 350. So I'll model this structure in ETABS. So let's move into ETABS. Here is a staircase also. So here there are 8 numbers of square column. 4 are in regular size and 8 are in angular direction. They are in 45-degree. So let me go to ETABS, go to new model, use built-in settings with Indian standard, and code are all of Indian standard. You have to select the code first. For now, let me select blank, then okay. So here the blank screen appears, in which we have the default grid system for Cartesian units. So let me go to add another grid system. We see that there are two types of grid system. The first one is, and by default one is Cartesian, in which rectangular grid system appears, and another one is cylindrical. So for this type of structure, we can use cylindrical grid system, or it is easy to use or model the structure with cylindrical system. So let me click OK, and I will modify it. So let me delete this one. Oh, sorry, I forgot to. Okay, then G1 cylindrical. Okay, so let me delete the Cartesian one. Oh, sorry. New grid cylindrical G1, and I have to delete the G2. Okay, I have to delete the, yeah. Then we have to edit this one. So let me go to add or modify grid system. Here we see the same window, but one is radial grid data and another one is angular data. Instead of Cartesian product, in which there are X grid and Y grid data in this window. So I can click display grid data as spacing. The first radius is 4.5, another one is 4.5 plus 6250 outer 300 to 50 deduction means 6.25 minus 4.5 minus 0.15 for center point 1.6. Then let me delete this one. So this one is 1.6. Okay. So here I think I will give the column of 45 degree because there are 8 columns. We have to make 8 numbers of 45 degree to make the 360 degree. So 45, 1, 2, 3, 4, 5, 6, 7, 9, 7, 8, 9, 45. We see here 45, 45, 45. Okay, it's complete. I have to delete this one. Okay, so the bubble size, let me select it int for all the system. Okay, so complete grid is formed, but we have to add a story height also. So let me go to modify story data. I have to add 3 more story here. Sorry, 1. Let me to add 2. Okay, the first one is 3.35 plus 0.65 4 meter. There are 3 story of 4 meter. Then another one is 3.35 plus 0.9 4.25. Another one is I think 1.5 meter. 1.5 meter. And this one is 3600 3.6 meter. Then 1.9 4 4.25 4.25 1.9. Oh, here we see there is master story. So let me remove the master story because we don't need any master story now. So if we give the master story and slice similar to click on similar to master story, then everything can be, suppose for example I have to work on story 3. I have to make the fluoride dimensions and everything. I have to I input in story 3 everything that are copied to another upper story. If we click or if we say yes to master story and similar to master story. So for now I don't have any master story. This one is 4.25, then this one is 1.5, this one is 3.6, and this one is 1.9, similar to CAD drawing. Okay, okay, so let me click. Okay, so we have already defined the grid system. Then let me go to define material. For this modeling I need two material, river and concrete. So let me go to define material. Here we see default material type. I will add new material, India concrete. Then I'll select M30 for now. We see if we select M30 or some specified grade concrete, all the parameter that can be used for analysis, for linear analysis, can be as well as nonlinear analysis, can be automatically displayed here. And we see material property data. It means M30 means 30 MPa, the strength, compressive strength of the concrete. For now, we don't have to go for nonlinear data. We can change the nonlinear data according to the material non-linearity. So for now, let me click OK. Then let me add another material, which is rebar. I will select HSIT grade 500. Similarly, all the data are displayed. And if we see the design property data, minimum yield strength of 500, tensile strength of 545, expected yield strength of 550, and expected tensile strength 599. In this box, if we have any experimental data, we can input this that experimental data, but in the absence of experimental data, leave these values. Okay, so the material definition has also been done, and after that we have to go to define the section properties, go to frame, add new property, rectangular. Okay, then let me keep column of 600 by 600, select the concrete grade, depth is also 600, go to modify rebar, column, select the rebar material, reinforcement to be design or check. In case of design, no need to edit this data, but after designing to check the structure, we can go either for the section designer, or if the structure section is simple, the rebar data can be input from here to check the adequacy of rebar after the design. So let me click OK. So let me click OK. Then I have to add the beams and shear wall as well. So add copy of property, beam of 500 into 650, width of 500, depth of 650. Go to so modify rebar, design only beam. Let me give 41, 41. Then OK. For modifier, I will not change any modifier for now. Then again add copy of property, beam 500 into 900. Go to change the depth 900, other things same. Then again another beam of 300 into 350 for upper ring beam, 300 and 350 for the depth, other thing remains same. Okay, so this much, and again I need to define the wall section. This one is, let me, wall 300, 300, select the concrete. Okay, then I'll define the dome slab, upper dome slab and lower dome slabs. Sorry, this one is well. Define section slab. Let me define, modify this slab. Slab 100. This one is 100. And let me delete this. Add slab 300 for lower dome. Okay. Then I start to model the elements in ETABS. So Yeah, first of all, let me define or draw the beam. I see quick draw beam here. All story. Okay, this, 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 and for another four beams, I'll make four columns. I'll make angular columns. Okay, this one, this one. Okay, so here for all the floors, column have been drawn, but I need to put the columns for only up to fourth floor. I think I have to delete from this level. Okay, one, two, three, four. So let me draw the beams. So for the story 4 beams of 500 by 900. Okay, the beam can be drawn like this also, connecting each grid. But for now, I'll model the circular beam. Okay, so for now, story 4. Let me go to define arc and arc center and 2 points. Here are the way to define the beam. By default, it's straight line, spline, multilinear, bezier, arc with 3 point and 2.4. For now, let me select arc center with another arc point, and I'll go here. You can select each point also. So each column point also. I'll go like this for now. Click this, and finally the last point is done. Okay, the beams of 500 by 900 in story 4, and in story 3 we have to go for 500 by 650. Let me select. Here we can see like this also. You can model again. Okay, yeah. Then I will copy this beam into rest of the 3 story. Okay, edit, replicate story where drawn on story 3, then go to story 2 and 1. Okay, yeah, you can see in extruded form the column of 600 by 600 and beam of 500 by 650 and this upper beam of 500 by 900. So let me go to story 5 now. Story 5. In story 5 we have peripheral beam. If we see in the story 5, here we have peripheral beam of 500 by 650. Then let me go to define 500 by 650. Go to this point. Sorry, I have to select the arc with radius. This point. Okay, this with this one. here to, yeah, we see in the elevation or 3D view. Okay, then from here to here we have to connect via shear wall, slope shear wall, here vertical from this level to this level vertical wall, and from this level we have to model the dome, and from this level to this level in the inner structure we have also to make the dome. So let me start to make a dome structure. So the inner dome structure is 4.5 meter radius, and this is in the height of 1.5 meter. So here the scale is not appropriate, so I will keep the elevation as 1.5 meter, and let me start to model this dome. In ETABS, this dome structure can be directly imported from AutoCAD in the form of .dxf file by making the dome's dome coordinates, or by importing the dome coordinates and model the coordinates with the assigned data in ETABS. But now I will go for manual modeling the dome in ETABS. So for that we need this radial distance and elevation or height. So let me turn into ETABS. Let me go to story 4. Okay, I'll keep this as story flow here, and yeah, let me select some elevation. Okay, yeah, we have to make a dome here. The first dome is like this, and the shear wall is like this, and another dome is like this. Okay, so let me get this. So here I am going for elevation 33 and 77, or I can choose any elevation 55 or 99. For now I go for elevation 33 to 77, so that I can divide this distance, which is 4500 mm. I will divide this 4500 mm into 5 parts. So let me go to draw different reference points. Here we need to go for elevation offset as y 900. Okay, because this grid 77, this is 900. So 900, then I go from this side. Let me snap all the points, select all. Okay, then 900, another 900, another 900, then from this point I'll go for 900 as well. Okay, so the reference point of 900 has been drawn, and I have to go for the reference plane for the intersection. Go to reference plane, then I have 1500 mm. So let me turn into CAD file. So this top height should be 1500 mm. Here is by mistake, due to the scaling problems. Here is showing 12.5. It means I have to go for first one is 1500 1812.5 minus 1500, 312.5. So I need to deduct 312.5 from every height. So 1748 minus 312.5, 1435.5, 1435.5 from this level. Okay, then another one is 1552.5, 1552.5, sorry, 52.5 minus 312.5, 1250, 1240, 1240, 1240. We can click anywhere in this level. 1240. Then another one is 1213.2, minus 3.5, 900.7, 900.7, 900.7, and the last coordinate is 703.2. It means 3.2 minus 312.5, 390.7, 390.7. Okay, yeah, we have forgot here. So again, let me go to draw reference point 900 from this point. Okay, then let me draw the first of all I will draw the beam and I will extrude that beam into or frame into cell element. Okay, so let me select one beam. So let me select 300 by 350 here, this one, this, this, this one, this, and this one. Okay, so I need to check the elevation of this level. Okay, because it is little sagging. So let me go to, okay, let me increase a little bit this elevation. So for this I will go for, because it is not usual, so I'll go for air modify curves, modify system, modify planes. This one it is 16.64, so let me put 16.75 and check. Okay, then I will draw this one here and connect to this one. I think it's okay now, so delete this one. Okay, so this one is the beam line, and we have to extrude this beam into dome slab. So let me select this beam as well, like this. So for now I have to extrude this. Let me select again, go to edit, extrude. You have to choose extrude frames to cell. Here there are two options for extrusion. The first one is linear and another one is radial. Let me select radial extrusion. So pick one point on the model. I will pick this point. You can pick this point as well. for now we have to pick this point. Then I think, sorry, let me give the angle of 10 degree. Now we have to copy this into whole periphery. It means up to circular one to the angle of 360 degree to complete 360. So 10-degree angle with 36 number of segment. It means it has complete 360 degree. And let me delete the source object because the source object is a beam. So I have to change into the slab. So let me click apply and click OK. Here we see the dome in the lower side or inner side of the structure. So let me select this dome. Okay, let me select, then assign this as a cell, and it is a dome slab. Let me check the thickness of this slab 300. Okay, then apply this one, slab 300. Okay, then it is of slab 300. Similarly, we can model the upper dome and the shear wall as well. So for clarity, I can delete these planes and reference point as well. Modify reference point, can delete this one. Okay, then reference point, sorry, reference plane, they can also be deleted. Okay, yeah, we see the, then we have to add a shear wall like this here and the dome structure for here. So let me go to define. So let me select this one and this one. Okay, then I have to make a dome like this from here to here. For that I have to go for again in the CAD. Okay, then I have to make this coordinate. So it is in the radial distance of 6.25 outer periphery. So I have to model these z coordinates as well for from the center to the outer periphery. The distance of each point is 597.2. Okay, so let me draw this reference point and reference plane in this model. For that, let me go to draw reference point. I'm going from grid 33, then I have to go for negative 744.5, 744.5, then yeah, okay, then 1341.5 minus 1341.5, okay, then 1938.9 minus 1938.9, okay, then 2536.1, 2536.1, okay, then minus 3133.4, 3133.4, then another one minus 3730.5, 3730.5 minus 4368.1, 368.1, then minus 4924.9, 4924.9, then 5522 point minus 5522.2, 5522.2, then another one is the center line. Similarly, we have to make the reference plane for that as well. So for reference plane, go to height of this first one 558.8, 558.8 from here. Okay, then 860.6, 860.6. Okay, then 1125.9. Okay, and another one 1355, 1355.5. Okay, then another one 1528.8, 1528.8. Okay, another one 1666.8, 1666.8. This one, another one 1775, 1775, 1857, 1857, 1857. Then the next 2 points are 1900. Okay, so let me draw the element. Okay, so here let me draw the beam element like this, like this, like this, 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 this one, this one, this one, this one, and this one. Okay, so you see this first point is little bit higher. We can edit this point like this. Go to add, modify grid system, modify planes. The first one is 20.98. Let me do 20.85 for smooth. 21.85. Okay, yeah, and let me again redraw this one, this, and this. Okay, somehow it is smooth in shape. Yeah, so again let me repeat the same procedure. Let me select all this, this one, and again go to extrude frames to cell. We have the radial extrusion and linear extrusion. Go to radial extrusion, choose one point on the level, rotate about that point. Okay, then also we have to rotate this one for 360 degree, 10 degree for 336 segment, and delete the source object. Let me click apply, then okay. Yeah, we see the complete dome structure. Here we have to select these, and these are of 300 mm thickness, 300 mm thickness. Okay, these are a 300 mm thickness. Let me go here, assign cell wall as 300. Okay, and this top dome is 100 mm. So let me select like this. I think we have selected all the elements. Then assign, go to cell. I have assigned as dome slab. Go to dome slab 100. Okay, yeah. So we see if we delete the grid system visibility and default shape, and let me extrude as well, we see the complete dome type structure in ETABS. which is very easy and interesting to draw as well, model as well in the ETABS. So like this way, we can model the elevated or overhead or intense water tank in ETABS. And at the base, let me select, we can assign the joint restaurant as well. Let me select this one. Okay, so in this way, the water tank can be modeled. And in the upcoming video, I'll go for apply the loads and analyze this model as well. Okay, so this one's for today. Till then, don't forget to like, comment, share, and subscribe my YouTube channel. Okay, thank you.